All right, last week, after this week, you don't have to think about math finance again. Well, maybe until the final. Anyway, any questions?
Ask a quick question.
You have a question?
Yes, a quick question.
Go ahead.
For the last homework, for question 2, I'm having trouble finding option data in like euros or the British pound or something. So I was wondering if there's like a certain website or something that I could try.
That was question for data explorations. So I don't have the answer for that. I encourage you to try to look for it. Now, if you can't, it's not going to be the end of the world, right? But try to see, right? Maybe I don't know, try Bloomberg to see if there's anything. Yeah, but again, right? Those are things that I think should be out there, but I don't know the answers. The point is, if you cannot find it and you try your best, it's not too bad. Okay, but I think there's something like that out there, right? I mean, even if you cannot access the data, maybe try a screenshot or something, if you can see something and then say there's such a data somewhere. Does that make sense?
Yeah, that makes sense. Thank you.
Yeah, I mean, again, right, you understand why you want to look into this, to at least have a sense that there's such data out there, right? If you cannot access it, that's fine. But I think, right, those should be listed, right? Or, here's a starting question for you. Do you think that Apple is listed? Definitely, right? Apple should be listed in the Shanghai index or something. Is it or not? I don't know. Or some, British exchange. So that's the first question, right? Is it listed or not, right? And then if it's listed, where can you find the data? And that's it. Maybe those two questions first, right? And whether you can access it or not is a different question. But I'll be super surprised if you tell me that no US stock is listed anywhere else. Does that make sense? So yeah. It's more like that question, right? Okay, is there a big name in the US stock that's listed under a different currency somewhere? Which data set, which exchange will store that data? You may or may not have access to it, but which one, right? And then the second question is, actually maybe the opposite too. Is there any foreign company that's also listed in their native country and listed in the US, right? That's the same question too. Does that make sense? Now, again, right, I understand that it's hard to maybe access the other ones, but the first question is there such a thing? And which data, right? Which database do we need to access, right? And if you can give me that, that's the starting point. Is that okay?
Yes. Yeah.
All right.
Thank you.
Sure. Okay, any other questions? All right, so I think maybe let's tell you, I think the final is planned on May 5th, 9 to 12 a.m. Location to be announced. All right, probably Hill Center, but we'll look into that. And what do I want to say here? The format is exactly the same, as the midterms, and it's going to be cumulative. All right. So let us finish the last topic of the course. All right, so the official name is change of numerator, which is a theory, all right? But I want to kind of bring it to the more of the more of the practical topic of exchange rate, okay? So again, you will see that the theory has broad application, and I'll mention that a little bit, but we'll focus on this because it's really a topic in itself in terms of finance. Okay, so first, let's look at the model or context, right? And here, even the finance, right? Like I said, the finance itself is quite complex. So let's look into that for now. So first, we will start out with the physical, okay, model. But not only physical, we also look at the domestic model. All right, so we'll have two assets. The first one is some kind of stock, and let's call it sigma 1. Let's call this W1. And then we have another one, which will be our exchange rate. Sorry, Q. And then sigma 2, and then rho, sorry, QT. BW2 plus square root 1 minus rho square. BW1. All right. So here, right, S is just some stock, whatever name you want. Q is the exchange rate. All right. And let us be very clear, right? Now, one of the things that you will find confusing in this section is we'll look at the exchange rate from both sides. And at some point, it's got to be confusing. And we talk about euro-dollar exchange or dollar-euro exchange. What the heck do we mean, right, by those? So, right, let's be very clear that when we mean domestic, right, well, since we're in the US, let's just pick that to be the US market. So the exchange rate here, right, let's strip away all the, fanciness and just really say, right, that's what it means is the price, right, of one unit, right, of foreign currency, yes, in the domestic currency. So that's still fancy, but what I really mean, right, is both of these, right, are in dollars, yes. The unit is in dollars, okay? And so Q, right, can be think of just like, Q really then is a price of an asset, right? It's a price of a euro, right, at time T in terms of dollars, or price of a yuan in terms of dollars, price of a pound, right, in terms of dollars. So fine, right? So that's, first of all, that's the context. Second, right, is about the model itself. So the model is nothing strange, right? This is just a good old, geometric model, right? Which I kind of asked you to explore a little bit in the homework because, stock can keep on growing, right? That's fine. Exchange rate is kind of interesting. I mean, this model is not that unreasonable. It's just that it feels like, right, the exchange rate tends not to always grow, right? You don't think of exchange rate keep on growing forever, right? I mean, the price of the euro doesn't, okay, stock doesn't have to be always growing, right? But here the model seems to say it grows on average, right? Exchange rate seems to stabilize, right? I mean, the exchange rate between the pound and the US dollars, or euro between the euro and US dollars, right? Don't seem to like, keep on going and things like that, right? It has a level, right? Has a fixed level, right? That it keeps coming back to. So it feels like it should be a mean reversal model, but anyway, right? That's for you to explore. This is going to be the model we'll be using. And so that's the first thing. The second thing though, right, is by necessity, right? We are in a two asset market, right? At least two assets. So we are in a more than one asset, right? And if you recall, right, in the discussion a long time ago about the risk neutral probabilities, when you have more than one asset, right, then the question of the existence of the risk neutral probability is not a trivial question, right? Before, like I say, you can just, immediately convert this to tilde and R, right? But now, right, you have to really be careful, right? Remember the homework. And first of all, right, so, and also that explains why we need two prime motions, right? okay? Because if we only have one source of noise, then, right, the risk neutral, the market price of risk equation solution, right? So that's necessarily we have two Brownian motions. But more importantly, right, how do you do the Brownian motions? Now you could have done, right, something like this, which is what someone may write. Okay, where W1 and W2 are independent. There's nothing wrong with this, right? You can still look at the math, look at the finance and study it. But in terms of the modeling, it seems like this is less interesting. Oh, by the way, right, I forgot to say here, right, the number row is between 0 and 1, right, for obvious reason. So you can do this, but this, right, obviously corresponds to a choice of row equals to 0, right? So, but you have more choice than that in this more general model, right? So what you are trying to say, right, is what? So do remember, right, what is sigma, right? Sigma is the, rather sigma square, right, is the variance, right, of the return, of the percentage return, or, you know, log return, right? It's kind of the same, right? So basically, again, this goes back to day one, right? When I was explaining how to model assets to you. So actually, to be fair, right? What we're saying here is DST over ST, right? Percentage return is a normal, right? With mean mu dt, right? Oh, sorry. So this is dt, right? And variance sigma 1 square dt, right? Something like this. So we're really, right, modeling the returns again, right, of these two assets. Even though it's probably feel a little funny to talk about the returns of the currency, right, exchange rate. But yes, right, if you think of it as just an asset, right, the price of a unit of something, then it, of course it has its return, right? But what you're saying, if you choose this model, is that the returns, right, of these two different assets are independent, which is okay, right? Again, you know, in the classroom, who knows? But in real life, right, you would have reasons to think, yes, that the price of a currency, right, might be correlated to the asset, right, the price of a stock, right, of a company, right? If a company, for example, has some business, right, in the other country, then maybe the price of currency of that company might affect, right, the stock price of that company, right? Think of some company that does import export, right, with another country. So the currency, right, price change, right, the currency becoming, right, let's say more expensive will definitely affect the stock price of that company, right? So what we're saying is that we would like to have, right, correlation between the returns, right? Again, right, this is just in case, no one will force you to use it, but having that, right, option. Oh, sorry, this is just row, right? Let me think. Is it row dt or just row? Row or row dt? I think probably row dt. Okay. So yeah, it's row dt. So basically, right, you want to be able to throw in a correlation component, right, between the returns of these two assets. And that's exactly, right, how this comes in. By the way, right, so this is a very interesting object in ourself. You can call that W3. Right? And by the way, right, this is how you actually you can play around with normal random variable in this way too. So what is it, right? What are we doing? When we do this, right? So here W1 and W2 are independent prime motion. Then clearly, right? I mean, well, not clearly. Then the conclusion is W3, right, is also a Brownian motion. All right. So now I'll ask you to think about the proof, right? Because it's almost obvious, but you know, you really want to check the properties of the Brownian motions, right? So in other words, starts at 0, has independent increments, right? The increment is normally distributed, right? All those properties need to be checked. But it's kind of easy, so I'll let you check that, right? On the other hand, right, what we have is clearly the correlation, right, between, let's say, W3 and W1 is rho times, it's just rho, right? Yeah, rho. Okay, it's just rho. So hold on. So this is rho or rho dt? I'm still confused. I think it's just rho. All right. Yeah, right, because the correlation here is rho. Okay. Yeah, you divide by the variance. That's correct. It's just rho. All right. So what you exactly, right? Which is exactly, you see this correlation here, right? So basically, the model that we're writing here is not dW2, right? But it's really dW3, right? Where we combine this into another Brownian motion that has a correlation component to the other one, right? The noise, the source of noise for the stock that we can calibrate, right? We can choose whichever one we want, right? So this way of writing is much richer, right? To model two assets model, right? Rather than just independent. Okay, so that's the first one that I want to talk about. You need two Brownian motions, and you can make it quite general in terms of the correlation structure of the two Brownian motions, which in turn will affect the correlation of the returns, right, of the two assets your model. All right, any question on this? Okay. Now, right, the second one is the second one, right, is this. So this is just the physical domestic context. Notice that, right, the one of the thing, right, in terms of finance and modeling in this section, right, is about exchange rate. So let's talk about the foreign market, right? So again, we'll get back to this later in a little more rigorous way. But the moment you write this down, right, normally if this is just something else, like another stock, then we have nothing, right, to look at. This is the only market we look at, and that, etc. But because this has a meaning of an exchange rate, the moment you write this down, you immediately have two other assets. The first one is let's call QF, right? QF is 1 over QT, which is, right, exactly the other exchange rate, right? So F here means foreign, right? Anything that has F here in this chapter means foreign. So this is exactly the foreign exchange rate, right? The exchange rate going the other way, okay? Remember I told you it's going to get confusing. So this is exactly the price of what? $1 US, right? In the unit of the foreign currency, right? So that's the first one. What else do we have? We will have the one that Kareem was asking about, and I was asking you to look at this one, right? I mean, we usually just do this, but we can also call it the SF, right? This is the price of, one share of S, right? In the unit of the foreign currency. Is that okay? So immediately, right, without even looking at anything else, right? Of course, this class is about derivative pricing, but even looking at the modeling of the assets, right? The moment you write down Q and S, because of the meaning of Q, you immediately have these two very meaningful, right? Assets, right, in the other market. Okay, so notice that both of these are denoted in the other unit currency, right? Like euro or something, right? Euro or yuan, whatever. All right. Yep, so that's the first thing. So immediately, right, there are many, many questions you can ask. So, right. First of all, let's throw in the routine questions. Domestic, right? So now you understand why we need to throw in the word domestic and things like that and foreign. Domestic risk neutral probability. What do we mean by this? We have a market, right, with two assets, right? What does the risk neutral probability look like? Meaning, right, what does S and Q look like under, right, DST, DQT, under, right, let's say under the risk neutral probability, right? So under P tilde, let's call it P tilde, right? Risk neutral probability. Now, you might think this is a trivial question, right? You know, well, what are you talking about? Just change it to R, tilde, 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 right? Easy. Not quite, all right? There's something going on here because of the finance. The second part is maybe, right, pricing, right, under domestic, right, risk neutral, right, framework. And again, this is probably routine, but still. So what I really mean is, right, so this is really, you know, standard stuff, but there's still something to talk about because what kind of product are we thinking about? Well, you can have the good old, right, call option, put option, whatever on the stock, right? We are very familiar with this, nothing new. But on the other hand, you can also have a call option on the exchange rate. Or, you know, for that matter, you can have put option on exchange rate, you can have, you know, American option, right? Whatever you want on the exchange rate. But, right, so if you pose this, right, what are V0? Again, not that hard, but still, especially this guy, because it's an exchange rate, right? Is there anything different from the exchange rate pricing to the stock pricing, for example, right? Option on the exchange rate. Right? By the way, option on exchange rate, right, are very routine, right? It exists. See, right, exactly what's this picture on the other side? Right, because you have the counterpart, right? The foreign people have the exchange rate going the other way. They look at Apple stock under their currency. Wow, what's going on there, right? Well, how does the Apple stock and how does the foreign exchange rate look from their side? By the way, right, I hope you appreciate this is not a very trivial question. It's not that hard, but you have to think about it. Why? Because, you know, if you look at Apple stock or whatever stock it is, right, from the foreign eye, notice it's not just this asset itself, but the currency also plays a role in the fluctuation of the price of the asset. What that means is, right, there's some kind of currency risk involved when you look at the price of the asset, right, the price of a stock under a foreign, you know, currency, right? Because, for example, suppose the stock has the volatility sigma 1, right? But the currency has volatility sigma 2. So when you combine that together, right, the fluctuations will, you know, interact. Yes. So that's exactly that kind of question. Of course, right, together with this, you have pricing, right, under foreign, right? Risk neutral. So what is this, right? This is going to be, by the way, right? So for example, now you have VF, right? First of all, you have SFT minus KF, let's say. You also have VFT, right? Which is QF minus K plus. But, you know, notice that interestingly, right? Let's just write it down like this. Sorry, KF, right? For example. Now, what's going on here, right? this is straightforwardly, just options, right? Call options on the Apple stock, but listed in foreign currency, or call option on, the exchange rate, but the price of the US dollar, right, in the euro. So notice I write KF here because the K and KF here are not in the same units, right? Here, right, K is in dollars, but KF here is in euro, okay? So obviously C and D are related. If you can figure out C, you can figure out D. On the other hand, right, so the interesting question is not about C and D, but about B and D, same as A and C. Is there any connection between A and C, right? And you would suspect that there's some connection between B and D, especially these two guys, right? Because one is a call option on the euro, right, from the US side. One is a call option on the US on the euro side. Or rather, right, you might suspect that one is a call on this side, one might be a put on the other side. Because, right, if the euro goes up, that means the US goes down, etc. Right? So what's the relation between these two? Okay, so connection between A, right, and C, and B and D. All right, and those are the questions that we will try to address. More importantly, right, so the theory behind all this is the change in numerator, right? So together be theory, right, behind this. So that's the finance I was trying to talk about, or that's the modeling, right? Change in numerator. All right, so these are the questions we will try to address, and we'll talk about the theory of this, right? And I want you to kind of follow and pay attention, because the concepts here, right? The math can be a little bit complicated, but the concept actually is a little bit more important. Okay, give me a moment, all right? I'll be right back.
Excuse me, so I missed the first time I asked the class. Didn't the question logistically?
No, it's just like last class, it's the end.
Oh, okay.
Yeah.
Think of the question.
Is it the final will be next Thursday?
Next Thursday.
May 5th.
Okay. Thank you.
So so it's 9 a.m. to 12 a.m. And he doesn't mention like the location. He said will be announced.
All right. Thank you.
Okay, so maybe let's start with the domestic risk neutral probability. So first of all, right, let's start with the financial question. What is the risk neutral probability? So, okay, so A, right? The question is, what is the risk neutral the domestic risk neutral probability? What do I mean by this? So for example, right, what I mean by this is actually I want you to be very, very cautious here and try to think about what we mean by this. For example, right, before we say something like this, right, the discounted stock price is a martingale, right? What we're saying is basically minus RT, right? ST, right, is a martingale under P tilde, right? So what that translates to is, right, you are indifferent between a stock price today and a stock price, right, one share today and 1 share, a month from now, right? You're indifferent, right? So all these are the same thing. So now we're in the market with 2 assets. Yes, one of them is rather special because one of them is the exchange rate. So what do you think, right? What should the risk neutral probability be in terms of the definition? Should the discounted stock price and the discounted exchange rate be martingales under the domestic risk neutral probability? All right. So, like I said, right, the intuition of the indifference between now and the future, I think, is a more robust intuition to keep in mind. So now, right, the stock obviously is still the same, right? Because I mean, asset is asset, right? But will it change? How about the exchange rate though, right? Or foreign currency? Are we indifferent between the foreign currency today and the foreign currency 1 month from now? Now, posed in this context, notice is a very, very abstract question, right? A little bit. Let me make it very easy for you. What is 1 unit of foreign currency? Well, how about 1 euro bill, right? Literally the 1 euro bill, right? So that actually is a physical asset, right? You actually cannot hold 1 share of this, but you can really hold 1 euro bill, right? So the question is, do you want to have the 1 euro bill today, or you want to have the 1 euro bill a year from now? What's the answer? Are you indifferent whether someone hand you a 1 euro bill right now or 1 euro bill, a year from now?
The one right now.
Because
Money.
it's funny you mentioned inflation. Right. I mean, let's forget inflation, right? Yeah, I agree with you, right? That is so amusing because inflation is not on anyone's mind, right? Like, let's say 3 years before or something. You're absolutely right. It's just, I don't know how inflation will come into this. But time value of money is perfect, right? So time value of money. So definitely this is preferred. All right. So clearly, the point is E minus RT QT is not a martingale, right? Under P tilde. Okay, that's the surprising thing. Maybe, maybe not. But let's say this, right? So Kareem said that. Now, or was it Kareem?
No, it wasn't
Was
me.
it Kareem?
No.
I'm sorry?
No,
it
it
wasn't
wasn't.
Kareem, right? Right? Sorry, because I cannot see who's speaking. But all right, so if you said, right, it's time value of money, then I discounted here already, right? So why is that still time value? Where does time value come from? Right? For example, here the stock price has some time value component, and that's why we discount it, right? And say it's a martingale. So what time value? I already discounted, right? So why is that? Are we sure? Or maybe that's already time value? What time value are we talking about? All right. So think about it, all right? But let me save you the suspense. The time value here is a time value in the foreign money market. Okay. So what we're looking at, this is a one euro bill, right? And you know there's this regulation, right? That I don't think you can deposit a €1 bill into the US saving account, right? You have to deposit the dollars in the US saving account. So if you take this €1 bill and you go to a Euro bank and you deposit it, what will you do? What will you earn? You will earn an interest rate of RF. Okay, the foreign risk-free rate for them cash. Okay, and okay, again, right, there's inflation, but let's forget inflation for now. The time value, right, that you lose out when you compare these two is not the time value in the domestic currency, but it's the time value that you lose out in the foreign money market. Okay, so that's the important thing. Now, so that hopefully clears things up a little bit. But here's yet another way that makes it easier for you to think about. All right, because it's very important. So by the way, right, conceptually, what are we saying? So let me tell you the target, right? And then I'll try to explain the target. So a target is really simple. DST is RSTDT plus sigma 1 STDW tilde T, like this. DQT will be R minus RF QTDT plus sigma 2 QT rho D tilde 1 plus square root of 1 minus rho square D tilde 2. All right. So notice, right? So this is the result. All right. So I'm trying to explain this result to you, at least intuitively. So clearly, right, exactly this is corresponding to the discounted stock price is a martingale under P tilde. All right. Now, notice that for the Q part, right, it's losing out on the minus RF component. So that exactly models the losing of time value of money. All right. So what's going on here? What's going on here is this, right? There is something behind the scene that we never really model to all the assets that did not model before. Because it's really simple. But the first one is called the domestic money market. The second is the foreign money market. Okay. So really, right, this is something that is used out there. And you can invest in the money market, right? But basically, by investing in the money market, basically you just deposit into a saving account, right, under that currency. All right. So if the saving rate is high, right, for US bank, then people would want to hold more US dollars, right? You have heard that kind of argument before. And that will, make the US dollars stronger, that kind of thing, right? But the point is exactly, right? The money market is a market people actively participate and invest in, right? And the Fed, right, changed the target rate, right, to kind of also control the US exchange rate in that sense. But anyway, the point is this, right? These are two other assets. But you see, they're very simple. Why? Because, right, the solution is just what? Something like this, right? So we never really model it. The model becomes more interesting when we look at stochastic interest rate, right? When R becomes a stochastic process. But, but here, right, we need to name these guys. Why? Because the relationship, right, between, let's say, the foreign money market and the Q, right, is what? Oh, by the way, right, what do I want to say here? No, sorry. Scratch this for now. I'm wrong. So this is the point of view of the foreign money market. Yeah, no, it's fine. But is it fine? Yeah, it's fine. It's fine. So what I want to say is this, right? The relationship, right, between Q and this is this, that basically if we want to, right, we want to view the foreign money market, right, from the US perspective. What the heck do I mean by this? What I mean is the right object to look at is MFT times QT. All right, and I would not invent another symbol for this. But if you do this, right, what are we doing? Basically, you see, right, that this asset, whatever it is the, so basically, right, this is the price of 1 unit, right, of the foreign money market. In US dollars. All right. And exactly, right, this guy will be indifferent. This guy will be a martingale, discounted. So this guy will be indifferent between 1 unit of this guy and 1 unit of this guy. All right. So basically, you will be indifferent between holding 1 unit of the foreign money market a year from now, or 1 unit of the foreign money market right now. When you think about it, right, it's basically what I'm trying to say, right? It's a really complicated way to say that, right? You have $1 bill right now, right? You will deposit it into the Euro bank, and then you will collect the interest in 12 months, and you get something, right? So either you give it to me in the dollars now, or in 12 months, you will give that amount to me in dollars. I'll be indifferent, right? Because I'm not losing out on anything. Understand? So you say that, you know, Triad, right? I will either give you $1, right? One euro, right? Translate to dollar right now. Or, you know, if you're patient, I will deposit this into the to the Euro bank and earn interest. And, you know, 12 months from now, I'll give that to you in dollars. You know, I should be indifferent between these two if I have no need to spend money and forget inflation for now, right? But so basically, right, this right here is like the right asset, okay? So basically another way for you to look at it like this. So yet another view, which we did not talk about, but the foreign money market, right, in the US, from the US point of view, all right? The foreign money market is like a dividend paying stock. Let me say asset. And actually, when I say that, it's not like, but it's exactly a dividend paying asset. What's the dividend rate? All right. All right. Now, we did not spend time, or I hope, I'm not sure if Casper discussed the dividend paying stock with you in Math Finance 1. Basically, this is exactly the model for dividend paying stock. All right. Why? Because when the stock pays dividend, right, you will earn this in cash, but of course the stock price will decrease to make up for that part that you earn in cash. So all in all, right, if you put these two together, then you don't lose anything, and that becomes, you know, the single stock again. Does that make sense? Okay. So to recap, right? The foreign money market will not lose out in value. So this guy will be this guy's price will be a martingale under the domestic risk neutral probability. If you just focus on the exchange rate, which I admit is the more natural object to look at, or the object to look at more often, then it's not a martingale because it will lose out on the foreign interest rate. Okay. So that's the explanation, and that's the important thing. Any question on this? Okay. So now I'll leave it to you, right, to figure out how we convert from, physical, right, to risk neutral, right? There's still something there, right? What is the change of measure, that kind of thing, but I'll leave it to you to figure out, right? Basically, the change is fine. Okay, so that's A, all right. B, pricing. Now, obviously, right, who cares about the regular option price, right? Okay, so that's easy. What I'm interested in is the call option on the exchange rate. By the way, right, you should not feel strange, or you should not feel anything that's wrong when I ask this. The reason is this, right? I mean, maybe after the whole talk about how this is not a martingale, you might feel like, well, then this cannot be priced, so it doesn't make sense to price this. That's completely wrong, okay? The fact that it's a dividend paying stock doesn't mean that, right? I cannot talk about call option on the share itself, right? At some time in the future. In fact, right, if anything, the fact that it's a dividend paying stock will make the pricing more interesting, yes? And in fact, right, what's the pricing? Well, it's the same as anything else. It will be risk neutral, discounted value. That's it. Right? So the message is, as long as you get the dynamics correctly, right? If you get this guy wrong, in other words, if you think that this is R, then your pricing will be incorrect. But as long as you get this right, then the pricing equation just follows the usual, structure. And that's why I asked, right? Remember, I asked the ds dq, right? That's why, right? It fits into the second question. Okay. So now let's test your knowledge here. But by the way, this can be an interview question. So suppose you're given this, right? And let me do this for now because it really doesn't matter, right? Notice that I can just call this, right? W tilde 3, right? Only when I discuss some relation between these two guys where these two should be separated. By itself, I just look at it as a prime motion. Can anyone tell me, right? You guys are expert on Black-Scholes. What is V0 in this case? Can you tell me the analytical answer to this question? You have 5 minutes to think about it. It's a phone interview question. Okay, so I know it's not been 5 minutes yet, but anyone? If you cannot tell me the the whole answer, at least tell me how you would approach this question. The point is, it's very easy. You don't have to do a lot. Anyone? All right. So why is it easy? Well, obviously you recognize, right? The difficulty was because, right, this guy is not R, it's RF, right? If only this were R, then you can do it, right? Because that's just Black-Scholes. Well, but why not? Because, right, so this part you cannot change. But what can you change? Well, obviously you can change this part, right? So you can do whoops. Isn't it? Right? And once you do this, then what is this? This is just Black-Scholes with R replaced by R minus RF. And that's it. Understand? So I won't write down. But so that's it, right? So that's the price of a call option on the exchange rate, right? It follows the Black-Scholes model, Black-Scholes formula, except you have to do some trick, right, to line up the rate. And by the way, that is exactly the same formula you would price a dividend paying stock because it's the same structure. Okay. Any questions so far? All good? All right. So let's do C now. So what is C, right? C now wants us to turn our attention to the foreign money market, right? So, oh, sorry, the foreign market, not foreign money market. So the foreign market has what? Has the order exchange rate, right? Which is this, and has the exchange rate, right? Oh, sorry, the stock price listed under the other currency, right? So what do I want to ask? I want to ask, well, what is the definition of foreign risk neutral probability, which is P tilde F, right? What I mean is, of course, right, maybe in English describe this, but also what is the dynamics, right, of this stock under the foreign currency. Okay, so far? So those are the questions. All right, so tell me in definition, what should this be? In definition, what should this be? Okay. Again, let's go to the indifference, right, concept. Are we indifferent between these two guys? Are we indifferent between these two guys? See how I say this is confusing, right? Because when you switch points of view, it just suddenly becomes so bizarre. The answer is yes. Because, right, if someone gives you Apple stock, one share of Apple stock right now in euro, or one share of Apple stock in a year in euro, what's the big difference? And by the way, right, do pay attention that behind this is just a very simple replicating or, what's it called, like hedging, right, question. Because, right, I mean, obviously you can buy one share of Google now, one share of Apple now, right, in euro, and keep that, and in 1 year you get that. So of course these two are the same, okay, in terms of preference. On the other hand, right, between $1 bill now and $1 bill in the future, I think this one is more clear, right? If someone hands you $100 bill now and say, I'll give that to you in euro, and then someone hands you $100 bill in a year, right, and say, I'll give it to you in euro, right? Again, I guess to Chang's point of view, right, you would prefer the $100 bill now, right, because of time and value of money. And in fact, right, I think it's more clear now that why? Because you will lose out on the US interest rate. Yes. Now, again, right, I do know it's so amusing because you mentioned inflation. Definitely inflation is somewhere here. But unfortunately, our model was constructed, I don't know, 10, 15 years ago, and we don't have inflation in mind when we construct the model, right? But anyway, right? So let's say that we will lose out on the interest rate, right? Time value of money from the US point of view, right? So this is not indifferent. And therefore, right, you see that the US saving account, right? The US saving account would be the one that you would be indifferent about, but not the US dollar, right? So in other words, you would think of something like this, right? So let me say that you would guess, because notice that this is complicated. Why? Why is it complicated? Because you invert, right? This, by the way, let me say this, right? This is not just symbolic writing. There's rigorous math behind this. Why? Because I have rigorous model for Q and S. Yes, so I can literally divide these two guys as processes. Okay, so these are very physical, very real process. But the reason why I say guess is because obviously, right, going through the math might be a little bit tedious. So we guess right now to just build up our intuition, and then we'll use the math to verify it. All right, but by guessing, I don't mean that what I'm saying here has no basics in reality. So the guess is, right, that DSF must be RF, right? Sorry, no T here because we assume constant interest rate. Okay. Now, but then, right, here's a kicker. What is the volatility? Is it still sigma 2? And then what Brownian motion are we using? Well, I guess, right, it cannot be the original Brownian motion, right? Because that's domestic, maybe a different source of noise. This is a little bit easier like this, right? Again, right, I hope you see what's happened, right? The minus R because it's losing out on the US value, right, of the money market, all right? What about the volatility? It's going to be, oh, sorry, it's not sigma 2, right? Sigma 1, because that's the sigma of the stock. Sigma 2, this, and let's call this W tilde, right? Maybe F. And what's the correlation between the two guys? Is it 2 rho? Do you understand? So, right, what I'm trying to tell you is this part is clear. Why? Because of the intuition of the finance that we just argued. This part is not clear because, right, martingale doesn't tell you what kind of volatility the process will come along with. right? Any volatility here you plug in will have, right, will still be a martingale in terms of discounting. Understand? So also right here, I'm demonstrating to you that, right, intuition can only carry you so far. There are certain parts that intuition may not do it. You have to really calculate the math. All right. So exactly, right? So this question is not that easy yet. Or not really about this, it's about this. So let me ask you, right? What do you think? Should this be sigma 1? Yes or no? And should this be sigma 2? Yes or no? Right? So the question is very simple, right? Try to phrase it in English. Is the Apple stock listed, right, in euro or in yuan, whatever? Does it have the same volatility as the one listed in the US market? By the way, I think that's one of your homework question, right? I asked you to do data exploration on that. The same thing, right, with volatility. Sorry, with exchange rate, right? Does the, I don't know, euro US exchange rate have the same volatility as the US euro exchange rate? Sorry, did I say it wrong? Whatever. See, it gets confusing, but you know, the two directions. What do you think?
I think it should be sigma 1. Like it should have the same volatility.
So same here and same here? Or same here and not same here? So
I'm
you
not
say
sure.
same here. I guess you didn't say anything. Yeah,
I'm not sure
what?
sigma 2. I'm not too sure about sigma 2, but I think sigma 1 for the stock, it should be sigma 1.
All right. Okay, very good. Yep. So Kareem at least is courageous to make a guess, which is always good. Except that I think you're just wrong on both counts. So first of all, it should not be sigma 1 here. Why? We can see from the intuition. As I allude to, right? SF is S over Q. So just, you know, again, right, what is volatility? Volatility is just contribution from noise, right? The fluctuation coming from noise. So intuitively, it cannot be sigma 1 because, right, sigma 1 only accounts for the fluctuation of the S. Now, if currency foreign exchange rate is a constant process, is a deterministic process, then yes. But foreign currency, right, the exchange rate brings with it its own fluctuation, right? So imagine if the US, right, exchange rate, right, for example, imagine if inflation only happens in the US and not anywhere else, meaning the dollar loses value, right? Then clearly the Apple stock listed in euro would have a very different behavior from Apple stock listed in the US, right? You understand? So in terms of the effect, right, there are two effects going on here. So sigma 1 cannot be the volatility of the stock listed in foreign currency because that did not account for the effect of the exchange rate. On the other hand, this is more or less sigma 2. Why? Because this is 1 over. Or when you think about it, right, it really is, the fluctuation is a fluctuation in terms of the variance, right? So suppose you think about it, right? If the US yuan exchange rate is very volatile, would the yuan US exchange rate not be volatile? Of course not. It will be, right, equally volatile because, right, in other words, actually, you see the 1 here doesn't do anything. Of course, right, you are right to suspect that it cannot be exactly the same. Also, the answer is actually, it'll be minus, right? We'll explain that. But the point is, right, I mean, roughly minus, all right? But basically, right, this accounts for, right, if this one goes up, then this one goes down. But in terms of magnitude, it's the same. Okay? But anyway, right, I'm just arguing this verbally, intuitively for you, so you can appreciate what we're getting, right? Also pointing out, right, what the math is, right, how hard is it? Okay. And the last thing, right, is the kicker is this. Any relation between Q tilde F and Q tilde. All right. Now, this admittedly is a very abstract question. You're like, what the heck? Why do you care? Why do I care? There are reasons to care, all right? And we'll explain that later. Because, you know, what am I asking for here? I'm asking for a change of measure kernel. Let's say for me to move from, I'll just write E tilde F, all right? Of something to E tilde of that something, like that, right? What is Z? I mean, right? You might expect there's such a thing. And by the way, this question is deeper than just the existence here. Because if there's no existence, remember, right? We kind of like, you know, we did discuss it, but remember when we move from E to E tilde, right? Meaning from physical to risk neutral. Remember I said something about there must be equivalent probability, right? Again, you guys probably don't appreciate it as much. But if they're not equivalent, that means there's some event that's impossible in one world, but is possible on the other world, right? Which is very bad because that allows for arbitrage. Same thing here, right? If there's no such connection, then there might be some event that's possible in the domestic market, but not possible, impossible in the domestic market, but not possible in the foreign market, which is strange, right? In some sense, these 2 points of view should be equivalent. In other words, you should be able to find something like this. All right. So that's going to be taken care of by the change of numerator theory. Okay. So again, I'm listing all these things out to make you appreciate, right, the complexity of part C. Okay, any questions so far? All right. So maybe let's call this C1, right? Let's call this C2, all right? Let's address C1 first, and then we'll address C2 later. C2 in some way is a more abstract answer to C1, but you know, it may not have any insight. Okay, so what is C1? C1 is really just about to settle, right? This part and this part, but maybe also this part, right? So let's wave our hand. You see, because really C1 cannot be answered without knowing how the heck can we get to, you know, the Newbron motion, all right? But let's just settle on the volatility part first. And let's see how we can wiggle our way out of that. How do we address C1? Well, we address C1 by starting from where we know, right, that things are true, which is from the domestic market. In other words, we just start out with this part because we know it's true and it exists. So here I have to write down the full form. All right, you understand why? Because I will need to look at the interaction between S and Q. So I cannot just hide this under W3, right? Notice, right? This is where I want to actually solve for the solution. Sorry, sigma 1, right? Sorry, no D here. Okay, agree? So this is a solution of this differential equation. All right, if you don't see how I solve, especially the second one, try to think about it. Anyway, right? Why is this helpful? Because it's very easy to write down, for example, what this is. What is 1 over QT? Notice that's QF, right? That's 1 over Q0 e to the, notice the miracle, right? RF minus R, right? Plus 1/2 sigma square, right? T, all right? Minus sigma 2, right? Rho e to T. Okay. So let's just take this for now, right? And see what we observe. So here you need to know something, right, about the connection between this and this, right? Which we spend a lot of time explaining. But notice, right, how to go from here to here. This exactly is this, right? This part comes from this and the fact that this is a Brownian motion. And this, right, is just this part. Agree? So that's how you go from here to here. So now, right, obviously I want to go back. You know, I can't really, because see, this is where I need to know how these guys are in terms of the foreign market, right? Because it's no longer, right? It no longer makes sense for me to look at this as the domestic Brownian motion. I need to look at them as foreign Brownian motion. But I have some clue, right? What's the clue? First of all, right, by the way, this is just the QF0, right? That's just QF0. I have some clue. First of all, right, this should be the drift. This should be the drift. So, right, that corresponds to exactly that. So I'm good. Second of all, right, this should be the part that somehow deal with the Brownian motion. And notice, right, this is minus. That explains exactly this part. Okay. And then you're like, yeah, but what about this? This is a plus because, right, notice this should always be a minus, right? Whether this is plus or minus, by the way, right? Even if this is minus, pay attention. If this was still minus, the solution here will still be a plus, sorry, still be a minus here. The change is a minus here, all right? You understand? Even if this was a minus here, so that's a little bit funny, but if this is a minus here, this is still a minus. The minus will change here, all right? So what happens is, right? Right, so what is this doing here? You might have a clue like this. This part, this will play some roles. First, it will play a role to, you know, so let's do this, right? Basically, if you try to rewrite this in the form that you expect it to be, so first of all, it's QF0, right? And then e to the RF minus R, right? Should be minus 1/2 sigma squared, right? It should always be minus. Then you are missing what? You're missing a single factor, right? What does that come in? That comes in as the change of measure kernel. So you would guess that something like this happened. Do you understand? So basically, right, going from here to here, there's a single sigma squared T missing, but that will get to be coming to here, right? And the new Brownian motion is the old Brownian motion with drift, right? So again, like a change of measure, but now we change from Q tilde, so from P tilde to P tilde F. All right, but that confirms one thing, that the volatility of this QF is minus sigma 2. Understand so far? I mean, sorry, volatility is sigma 2, all right? It's just that it goes with the minus, but when you say volatility, you mean the standard deviation, so it should not be minus. It should just be sigma 2. But there's a minus sign in front because of that. Any question?
Can I ask a quick question?
Yeah, go ahead.
Is this also a minus sign before the first term RF minus R minus 1.
Oh, yeah.
Should be plus
Yes,
R.
yes, Sinan. You know why? Because I missed the minus sign here, right? There's a, wait, hold on. No. Wait, hold on. There's no minus sign here.
Yeah.
Wait. No. So why do you expect a minus sign here? You mean
No,
the minus sign here?
I mean,
What?
is minus 1/2 sigma squared or plus one
You mean
half
here?
sigma? Yeah.
You asked if it's a plus or a minus, right?
Yeah. Is it
Because
plus? Because the last term is plus, so I'm wondering.
Yeah. So exactly, your question exactly what I tried to explain, right? This is a plus, right?
Yeah.
But I insist it's a minus, right? Why?
Oh, I see.
So the reason is because the discounted, right? The discounted e to the minus RF minus R QFT is a P tilde F martingale. So basically, this is the part that will cancel out the Black-Scholes, sorry, the Ito, right? Second derivative terms. So, but no, right? Question is good, but let me tell you, right? The difference is going from here to here. I changed it to a plus to a minus here, but I also changed this to
Okay.
new Brownian motions.
Uh-huh.
Do you understand?
Yeah,
So-
I understand.
Right. So it's no longer, right, the Brownian motion under the domestic market. This is now the Brownian motion under the foreign market,
Okay.
right? Which
Yeah.
understandably the old Brownian motion plus some drift, right? I did not explain to you clearly what this drift is because I did not discuss the C2, but I was trying to build into that it must lead that way. There's no other way it can go. Does that make sense?
Okay. Yeah, I know that. Thank you.
All right. But so right now, right, notice that, so, right, Shinan's question, for example, I'm really trying to just address to you that the volatility term should be minus sigma 2. That's all, right? From the pure calculation, that's what I want you to expect. How this goes will be a longer discussion, right, on Thursday. All right, so now let's quickly address the SF, right? SF is ST over QT, right? Which is what? First of all, you divide, right? S0 over Q0. All right, what about the exponential term? Notice, right, we have the R cancel, right? And then you have the RF. So, but then, right, you have the volatility, right? Minus 1/2 sigma 1. So plus 1/2 sigma 2 squared minus sigma 1 squared, right? And this times T, all right? And then notice, sorry, E here, right? Notice that you have the sigma 2, right? Times, sorry, sigma 1 minus sigma 2 times rho for this one. All right, and then minus sigma 2, right, times 1 minus square root 1 minus rho. Agree? That's from division, right, between this and this, and then this and this, right? There's no W tilde 2, so it's just that. So what do we expect? What we expect is going to be, this is going to be SF0, right? E to the RF, right? And then maybe minus some term that we will quite put it there. But the point is, right, there's going to be sigma 1 minus sigma 2 rho square root of, sorry. So there will be W tilde 1F minus sigma 2 square 1 minus rho square W tilde 2F. Okay. So the volatility term of this guy is more complicated. But it's not that hard to see what's going on here, right? What's going on here, right? So we'll look at this later. But what's going on here is that the volatility here, right, will be the sigma 1 minus sigma 2, roughly, where the WTO1 is present, because you're dividing by it, right? Sigma 1, where was that? Sigma 1 minus sigma 2, right? That's the interaction here. And then where W2 is not present, then it will be minus sigma 2. So all in all, right, the volatility term for the stock, right, listed under the new exchange, right, on the foreign market exchange, will be not sigma 1 at all. It will be two terms, even though it started out with one term, right? It will be two terms because now it will drag in the Brownian motion from the exchange rate. And then, right, roughly speaking, is sigma 1 minus sigma 2 when you have the same Brownian motion present, and you have minus sigma 2 when you only have the other Brownian motion present. All right. So to nail this down exactly, we need to have the precise knowledge of how this convert, okay, which is C2. So we will continue with that. All right, next time.
Thank you, Professor.
Yep.
Professor, can I also ask a question for this part? Is that
Sure.
sigma 1 minus sigma 2, they both need to multiply the row or only sigma
Sorry.
2?
Yeah, I think I did. I
think
did
the
wrong,
row
right?
need to
Should be,
connect with
oh,
the
right.
sigma
That's
2.
right. Yeah,
yeah.
You're right.
Okay.
Yep, you're right.
Thank you.
Thank you.
I just want to make sure if it is this.
No,
okay,
you're
so-
absolutely right. I wrote it wrong, and I didn't mean for this to be precise because we will fix this right next time,
Uh-huh.
right? But
Okay.
this is more precise. Okay.
Yeah.
All right.
Thank
Thanks, Gina.
Thank
Yep.
you. Bye.